Okay, so let's talk about the law of cosine. So we started off this new unit with the right triangle. We did SOHCAHTOA, and then we got SOHCAHTOA from the last unit. So once again, so the aim is the law of cosines. Okay, and so what's going on with the law? So we moved past SOHCAHTOA, right triangles, and we said, you know what? We can actually find relationships between the sides and the angles. And I said before, it was always like sides are over there, like Pythagoras theorem, and angles were over here. Like the sum of the angles is 180, and they never like maybe these angles are complementary or supplementary, and those sides were equilateral or scalene. But we started to bring them together, and then we brought them together with the area of a triangle, and then we did law of sum. We were able to bring them together. So another way we can bring the sides and angles of a triangle together is the law of cosines. So you might have seen the formula. And so if you take any triangle, and let's call this side A, let's call this side B, and this big angle C, I can find this opposite side with the equation c squared equals a squared plus b squared minus 2ab cosine c. Couple of things. It kind of looks like the Pythagoras theorem, but now it's any triangle. It's an obtuse, it's an acute, maybe it's a right. So we take care of that with this extra part here. The other thing is the side you're looking for, and it's opposite the angle. So once again, we're using ABC, but we can use any letter. But let's figure out where this formula came from. So you can skip past this. I mean, I'll tell you when it's over, but I want to derive it for you. So let's start over again. So we started chapter 9 with the unit circle. And so we drew a rotation here, and the length of the terminal ray was 1. And we kind of dropped an altitude here. We said that if this rotation is theta, we called this side, this was sine of theta, and the base we said had a length of cosine theta. And therefore, this point was cosine theta, sine of theta. And so that's how we developed the first chapter, and all the sine, cosine angles, all the special angles, and we developed the whole structure of trigonometry. But then I started dropping problems on you. I gave you different problems, and I said, well, the sine of theta equals 4 over 5, and theta is in quadrant 2. And I asked you to find cosine of theta, and you said, okay, no big deal. We make another circle, the idea is we draw the rotation. The rotation was in quadrant 2, and we dropped the triangle here. So, this was a rotation of theta, and it was 4 over 5, so its opposite was 4, and this side was 5, and then, we found the third side, we said it was -3, and we knew the answer was -3 over 5, but if you look at this picture now, and I kind of, I said, well, wait a minute, if we don't have a unit circle anymore, we actually have a circle of length 5, and so we can kind of expand this idea. So cosine theta, sine theta, actually there was a 1 in front of here, and so we could technically say that this point here is, 5 cosine theta, 5 sine theta. Now, some of you might have seen that in the complex numbers unit, this idea of, going at an angle to a certain length and then a rotation. But the idea here is we can expand off the unit circle. It could be any length. So let's take that picture. So let me move my computer over. So let's get back. Let's get back here, and let's do a rotation. Let's do a rotation of C. I'm going to call that angle C, and the length here, I'm going to call it B. I'm going to call that length B. Now, this is kind of the cool part. Well, this unit is about the triangle, so you know what? I'm going to draw a triangle here. I'm going to draw a triangle, and we're mathematicians, we can do whatever we want. So I'm going to draw a triangle here to this point, and I'm going to call that point A0, right? Which means this length is A. And so the goal is, how do I find side C? Well, I know that C is a distance. And I know this point is A0. And we just figured out that this point actually is B cosine C, B sine C. And therefore, C is equal to basic distance formula, the square root of B cosine C minus A squared plus B sine C minus 0 squared. It's just the distance formula, right? Well, I'm going to take that square root away, and I'm going to do this is just a squaring a binomial. So B cosine C minus A is B squared cosine squared C minus 2AB plus A squared. And then what's going on here? Well, B sine C minus 0, that's just B sine C. And so I have plus B squared sine squared C. Well, let's move this around a little bit. We have C squared equals A squared plus B squared sine squared C plus B squared cosine squared C minus 2AB. Oh, I'm sorry. This was 2AB cosine C. Sorry about that. 2AB cosine C. What's going on here? Well, if I factor out a B squared, then if I have sine squared plus cosine squared, well, what's cosine squared plus sine squared? 1. We have C squared equals A squared plus B squared minus 2AB cosine C. And this is known as the law of sines. If you have two sides and the included angle, you can find the third side. Or if you have three sides of a triangle, you can now find any of the angles. This is really cool. So that's the derivation of it. You're not going to be asked to derive it, and you are going to be given the formula sheet. So let's just do some examples here. Oh, sorry, I just cleaned the board. Sorry. Let's just do some examples here. Let's see. Move over here. The first example I'd like to do is here's a triangle, example 1. Here's a triangle. It's a 5, 100-degree angle, 8, and we're looking for the side C. Please remember the formula. I can use any letter I want. The way I teach the kids to do it is first do C squared equals blah, 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 cosine of 100. The missing side and the opposite angle. What goes in here? Okay, 5 squared plus 8 squared minus 2 times 5 times 8 cosine 100. Now, I tell you to put it in the calculator, do n solve, or just put this entire expression in the calculator and then take the square root of it. But let's do a little algebra. Some kids, I think you want to do the algebra, fine. There's one little issue that might pop up. So we have C squared is equal to 25 plus 64 minus 80 cosine 100. We know that, so we have C squared equals 89 minus 80 cosine 100. Do not write 9 cosine 100. Do not do that. Order of operations says it's 80 times the cosine. At this point, you have to put this whole thing in the calculator. Once again, if you have cosine 100, you know it's a calculator problem. Do not write 9 cosine 100. Do not do that. So we have C squared equals 102.892. I wouldn't even write this down. Just let the calculator do all of the digits, and then C equals 10.1. Now, let's try another one. Here's a triangle, and let's do another one. 11, 39 degrees, 9, and let's call this D. And so you want to find length D. So once again, we have the formula. So once again, the way I do it is D squared equals blah, 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 cosine of 39 degrees. Once again, please remember the missing side opposite the angle that's given that you're using. You don't need to use the longest side. Clearly, this is not the longest side. But whatever side you use, that has to be opposite the angle. And once again, in your calculator, make sure you put it in parentheses. What's going in here? 11 squared plus 9 squared plus 2 times 11 times 9. You can put the whole thing in the calculator again, and then take the square root. Let's do the algebra because I can't help it. What do we have here? D squared equals 121 plus 81 minus 198. Yeah, right. 99 times 2, 8 carry the 1, 198. Cosine of 39. This we can clean this up a little more if you really have to. 202 minus 198 cosine 39. This goes in parentheses in the calculator. There's nothing we can do here. Do not do 202 minus 198. I don't see 198. I don't see 198 anywhere. It's 198 cosine 39. Stick this in the calculator. You get, what do we have? We have D squared equals 48.251, and then D equals 6.94. The only thing you need to do, the only thing IB wants to see is this and this. Let's go on. Question number 3. You might say, well, does this work for right triangles? Does this work for right triangles? Yeah, the answer is yes. Let me move the camera over. Does it work for right triangles? Okay, well, you know what? Number 3. Here's a right triangle. Here's 3, 4. Let's use the law of cosines to find sine E. So you're like, okay, we have the formula for the law of cosines. It's E squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 90. But what is the cosine of 90? It's 0. If this goes out, Pythagoras theorem. It's kind of cool. So E equals 5. Plus or minus 5, but we're back to basics. Now we're back to regular triangles, so we don't have negative sides. But please remember, we might have a negative side. In this case, E would be 5. Question number 4. Now we found the missing side. Let's find the missing angle. Let's find the missing angle, and then we'll get back to what I was talking about with the acute and the obtuse. Number 4, let's take a triangle, 10, 15, and 11. I want to call this angle F. Now, first of all, is this triangle even real? Because I can just make up stuff off the top of my head. Well, we know it's real because 10 plus 11 is greater than 15, and 10 plus 15 is greater than 11, and 11 plus 15 is greater than 10. So we do have a real triangle here. The question is, can we figure out what the angles are? And if you think about it, we've never, oh, my mouse is on the screen, sorry. We've never, once again, this is a breakthrough. We've never brought these two things together. We've always, I told you about a 3, 4, 5 triangle, but we've never discussed exactly what the angles are. And we kind of was able to do that with the inverse sine, inverse cosine, but what's going on here? Well, let's put the formula together. 10 squared equals blah, 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 blah. Cosine of F, let's fill the rest in. 11 squared plus 15 squared minus 2 times 11 times 15. Let's clean this up a little bit. I want to make a point. I mean, obviously you can stick this whole thing in the calculator. Let's do the algebra. So we have 100 equals 121 plus 225 minus, what's 30 times 11? 303. 330 cosine F. Once again, this is a calculator problem, but I want to do it by hand to make a point. Once again, what's going on here? We have 100 equals 346 minus 300 cosine of f. Okay, negative 246 divided by negative 330 equals the cosine of f. Now, the negatives go out. So obviously, you're going to do the inverse cosine of 246 over 330. And you don't even have to do that. Once again, you can dump this whole thing in n solver. But I'm going to make a point here. This is f. What does it turn out to be? It ends up being, the answer is 84.6 degrees. I think, maybe I made a mistake. Check it. I make mistakes. Yeah, the point I want to make here, right here, let's take a look at right here. Because this was great because immediately we know that we can tell what type of angle f is. Because unlike sine, we don't have a problem with cosine. Because the great thing is cosine of f is greater than 0, then we have an acute angle. Because we're in the first quadrant. If the cosine of f is negative, we're in the second quadrant and we have an obtuse angle. And to round it off, if the cosine of f is equal to 0, it's a right angle. And there's no other, because we're only dealing with triangles. And that's what's really cool about the law of cosines. That's what I like about it. Sine gives you that problem. You don't really know what quadrant you're in, or if it's acute or obtuse. With cosine, you definitely know where you stand. I think that's it. The last thing is, and just this might be a part 1 question. Prove that the angles of an equilateral triangle are 90 degrees. So we can do theoretically, prove the angles of an equilateral triangle are 60 degrees. So let's make our triangle, and let's call the sides x, 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 right? We know the answer is 60 degrees, but let's use the law of cosines to validate that. So let's see. So let's call this, what letter are we up to? F. We're up to g. So we have x squared equals x squared plus x squared minus 2 times x cosine of g. X squared equals 2x squared minus 2x squared cosine of g. I'm going to move this over, so I have negative x squared equals negative 2x squared cosine of g. Divide both sides by negative 2x squared. We have the cosine of g equals 1/2. 60, g equals 60, or pi over 3. And that's how the law of cosines validates that the angles of an equilateral triangle are 60 degrees. And that's basically the law of cosines. Good.